Hello dear friends, welcome to my channel. Today's discussions is propagator in quantum field theory. Okay, in quantum mechanics and quantum field theory, the propagator is a function that specifies the probability amplitude for a particle to travel from one place to another in a given period of time or travel with certain energy and momentum. So friends, this is very important topic. Okay, so in Feynman diagram, which serve to calculate the rate of collision in quantum field theory, virtual particles contribute their propagator to the rate of scattering event describing by respective diagrams. Propagators may also be viewed as the inverse of the wave operator. Okay, inverse of the inverse of wave operator. Okay, so this is the factors. Okay, inverse of the wave operator appropriate to the particles and are therefore often called causal. Okay, causal or Green's functions. Okay, non-relativistic propagator. In non-relativistic quantum mechanics, the propagator gives the probability amplitude for the particle to travel from one spatial point x dash at time t dash to the another spatial point x at a time t. Okay, consider a system with Hamiltonian h. Okay, so this is propagator. Now this is very important topic. Moments causality, the fact that we need to be able to determine whether a certain event in space-time can be causally linked or basically can be a certain event have caused a certain different event based on how far apart they are in space-time. So that's one of the most important concept in spatial relativity. We want to apply it, of course, to our quantum theory, and we will see that used to be an issue in quantum mechanics, but it is one of the things that we will solve in quantum field theory, and the way that we will solve it is actually very interesting. Rather, it has already been solved by just how creating this theory. Okay, in non-relativistic QM, we have the amplitude for a free particle that would propagate a certain point x0 to x. Okay, x0 to 2x. Amplitude for a free particle to propagate get from x0 to x. Next, ut. Okay, this result is very important. Ut, yeah, this is the amplitude e to the power minus I ht and x0. Okay, so this is the now we know that Hamiltonian h equals to, okay, h equals to p x divided by e to the power minus I p square divided by 2m into t divided by x0. Okay, so this is the Hamiltonian. Now a little bit, so let's now use the completeness relations. Okay, we know, please check, I have already discussed this topic, this formula identity dqp p into p. This way it can be written. Now another is xp. Okay, so it can be written as this way, 1 by 2 pi whole cube into e to the power I, and this way inner product p x0 can be written 1 by 2 pi whole cube e to the power minus I p x0. Okay, so this is the simplifying factors. And now ut ipx divided by divided by 2 pi whole cube and e to the power minus I p square t divided by 2a. Okay, so this equation can be written as, one step missing for, and those who are beginner they cannot understand, so this that's why I need to explain this way, that it can be written as, okay, ut can be written as this way. Just apply this formula, so I get dqp, okay, and this expression x into e to the power minus I p square t divided by 2m, and this equation can be written, so this way it can be written. Okay, because just putting identity operator. Okay, identity operator, I am using this operator. Okay, so now it can be written this way, just putting the value x into this value. Okay, and xp0, this result I just used in here. Note this result I just used because x into p, x into p and p into x0, so this result if I used this, so I get this value. Okay, from this I get, and using this result, bracket notation, using bracket notations property. Okay, so very simple. Now reminder, the reminding user using which prop I will remind. Okay, that reminder factor, the Gaussian integral. Okay, minus infinity to infinity e to the power minus b x square dx. Root over pi by b. this formula I used. Where this in here, so I can write this way, that more simplifying this, that 1 by 2 pi whole to the power 6, okay, and d cube p e to the power I minus I p t square divided by 2m plus I p x minus x. Okay, this property I just used in here. So now complete the square. So I just complete the square and I get this way, 2 pi whole to the power 6 integration divided by 2m, and very large expression m into x minus x0 divided by t whole square minus m square by t square x minus x0 whole square. Okay, so minus I t divided by 2m into x0 whole square d cube p e to the power minus it divided by 2m into p into m into x minus x0 divided by t whole square. Okay, very simple. Now friends, now we take this marking this is the v, we call it v. So we can write this way, 1 by 2 pi whole to the power 6 into e to the power minus it divided by 2m x minus x0 whole square, and it is written as p into e to the power minus it divided by 2m into v. Now friends, I will show this equation. How can we get these equations? Square term, okay? These expressions from this expression. So now note how I get this, that note, complete the square, okay? Complete the step is very important for understanding, that minus I p square t divided by 2m m plus ip x minus x0, okay, can be written as the whole square form. Just it divided by 2m, and I can write this is the p square, and this portion is multiplied in this way, that 2p divided by t, okay, x minus x0. Okay, now just adding square term, we can write this way, minus it divided by 2m p minus m into x minus 0 divided by t whole square plus equations, you can get these results that x minus x0 whole square, okay, and divided by whole square into m square, okay. So this equation is equal to minus m square, okay. Result is equals to this result is this result, okay. So how can I get this way, okay. So this is my note, and this step I just discuss for you that you can understand, okay. So those who are beginners, they can understand. Now I have already told that I used Gaussian integral, okay. So according to the Gaussian integral, b equals to, in here, b equals to it divided by 2m, okay. Gaussian integral I have already discussed in my channel. So results is ut equals to e to the power I m divided by 2t divided by x minus x0 divided by 2 pi whole to the power 6 into root over pi it okay, this way I can write that I by m, it by 2m, this is the whole cube, okay. So this way I can write, and I can write this way that ut is equal to e to the power im divided by 2t x minus x0 divided by 2 pi whole to the power 6, and now causality or the speed of light as we usually call it, that's okay. So we can say that E equals to, okay, so we get this portion, this number, this is the I numbering this is 1. Now let's discuss. E equals to, we know E equals to root over p square minus m square, okay. And we have to know that in the Heisenberg pictures, the amplitude for a particle to go from y to x is given by Heisenberg pictures, okay. Pictures, the amplitude for a particle amplitude for a particle to go from y to x is given by bra x ket y. This is the inner product, can be written as vacuum, okay, vacuum act on our field phi x our field phi y vacuum act on vacuum. We are just getting to write it like this: d of x minus y. Okay, so it is going to be our propagator. This is called our propagator. But so far just makes sense, nothing particularly new. We are now going to be working with fields, so let me quickly remind what the expressions for our field is. Phi x equals to integrations d cube p divided by 2 pi root over 2 ep ap e to the power minus ipx plus ap dagger e to the power minus ipx. No, sorry, e to the power pi plus ipx. So this is the equations. This equations is very, very important. Now we have different momentum, so we need to use different variable. So dxy, plugging this in here, so our momentum is different. Write that dx minus y, okay, dx minus y equals to 0 integration dqp divided by 2 pi whole cube root over 2 ep ap into e to the power minus ipx and ap plus ap dagger e to the power I px, and this is a very large equations, so it is going to very large, okay, into again d cube p divided by 2 pi whole cube and root over e, obviously defined variable, so it is q, and aq e to the power minus ipx a plus q dagger e to the power I, sorry, it is not q, iqx e to the power I qx, and get 0 means this is vacuum, okay. So 0 is get 0 means vacuum. So now, okay, I will change the site very soon. So now, of course, doing this calculation would be quite lengthy. So let's just take a look at the AP and AP plus and AQ plus, because we know that there are some relations with them, and the vacuum, right, 0 here the vacuum. So notice the following, or our on, remember the, we know that on destructions or annihilator operators acting on the vacuum will give us 0. This is of course also term for 0. So this results, we know AP acting on vacuum equals to 0 equals to AQ acting on vacuum, so it is 0. We also know you can basically take the complex conjugate here. So bra bra 0 acting on dagger aq dagger equals to bra, okay, bra 0 aq dagger equals to 0. So they are annihilator operator. So now I just take a look at terms with AP, AQ, A plus B and AQ plus B. So just multiply that everyone can, yeah. Now check my work. So this is the total work mine. Yeah, inverse wave operators, and this is this way you get. And now I apply some results. You see that these results I used in here, okay, these multiplications. So let me check that 0 AP and AQ 0. So this is 0, okay, and again you see 0 AP and AQ 0. The term, okay, this is the same, this is also same 0, and similarly we get 0 AP dagger and AQ 0. So this term is also 0 equals to AP dash 0. So plugging these results in here. So we get the value is d x minus y. So dqp divided by 2 pi whole to the power 6 dq key 1 by 4 ep and eq, and we get only this term, and otherwise all term is 0. ap e to the power minus ipx and a plus q dagger e to the power I q y, and this. So and now we can use d cube q root over 4 into eq into ep, and we can write this way 0 and ap e to the power minus ipx and a q iq y and 0. Okay, so this portion, so we get this portion. Now we can write this way, that again we are this portion, talking about this portion 0 ap e to the power ap and a plus q this way, and into e to the power minus I px plus I So friends, we get this value that AP A plus Q, and reminder that AP commutative and A plus Q. Okay, so this value is 2 pi whole cube del cube P minus Q equals to AP A plus Q, means A plus means dagger. Okay, A dagger Q minus A dagger Q into A P. Okay, so this value can be written that AP A dagger Q equals to 2 pi into del cube P minus Q P minus Q del cube P minus Q plus A dagger Q AP. So use this value in here. So we plugging this value. So whatever we get e to the power minus IPX plus IQY 0. Okay, vacuum means 0. Okay, 2 pi whole cube P minus Q plus A plus Q. A plus means A dagger Q, APU dagger operator, and 0. Okay, so apply this and annihilator properties. So using annihilator properties, so it is 0. So we get the value equals to e to the power minus I px plus I qy into the value is this is going 2 pi whole cube into del cube x p minus q 0. Plug in this value, so we get dx minus y equals to double integration d cube p into d cube q divided by 2 pi root over whole to the power 6 into 2 into root over ep into eq into e to the power minus ipx plus iqy 2 pi whole cube into del cube p minus q. Okay, now Dirac delta functions kills the integral terms. Okay, kills q. So I just kill the term, so I get only one term, 2 pi whole to the power 6 2 ep e to the power minus ip x minus y.